Good morning, all of you. Very good morning, Shivani. Good morning, all of you. Hope you all are fine. How was your weekend? Saturday, Sunday? All the days are holidays? I hope it was fine. Great. So, first of all, let us see the things that we have seen in the previous week, and then we'll start further. Just a minute, let me share the screen. Okay, so sharing my screen now. Just a minute, it's taking a little bit of time. Okay, so is it visible to all? Okay, thank you so much for the response, Shivani and Drashti. Great. Fine. So let us see the things. The response me here. Fine. So in the previous week, we had discussed about data warehouse. What is it? A definition we have seen, and in that definition, we are having four: subject-oriented, independent, and non-volatile. We discussed all the keywords also from that definition. Excuse me. Then we had seen the differences between OLTP, OLAP, your database management system, and data warehouse. What is the difference with respect to different points? Then we had also seen that we need to store data in multi-dimensional model. So in that, you are having hierarchies, you are having this kind of cuboids. You're going to prepare the combination of 2, 3, 4, and the cuboid with 0 dimension known as apex cuboid, and the cuboid with highest dimensions that is known as base cuboid. And then we had also seen schemas. So in database management system, DBMS, if you want to create database, then to create database, you need to have designs. That is your ER diagrams. Fine. So that ER diagrams you're going to refer and you're going to prepare as database design. And same way, if you want to prepare data warehouse, at that time you need to have designs, and those designs are nothing but schemas. And so here you are having three types of schemas: star schema, snowflake schema, fat constellation schema. And we had seen all in detail. At the center, you are having fact tables where you're going to store various keys, or you can say that, let us say, these are various tables or dimension tables. These are the keys which are going to refer to those tables. And you're also going to store other data like measures, average sales, unit sold, and all. This star, this snowflake, this galaxy. Okay, so I think we had seen up to this, right? So in the last, at the end, we had seen this galaxy schema. Now, why is galaxy? Why the name is galaxy? Maybe we had discussed it. Let us revise that thing again. This is called galaxy schema or fact constellation schema. Why it is galaxy schema? Because here you are having so many stars. For example, this is star schema. So you are having so many stars here, and maybe possible that more than one fact table is going to refer to common dimension tables. Now we need to start from this. Fine. So in this chapter, we are having architectures also, so that we are going to discuss later. So in today's session, we are going to discuss the kind of operations that you can perform on this kind of multi-dimensional data. Fine. So we had seen that you are having, let us say, data stored at a particular single place. Okay, let us go through that topic again. Okay. So here, at this point, you're going to store all the data at a single place. Then you're going to separate out with respect to different dimensions like time, item, location, supplier. That is your 1D cuboids. Then you're going to create a combination of 2, that is your 2D cuboid, combination of 3, 3D cuboids, combination of 4, 4D cuboids. Now, assume that you are having maximum 3-dimensional data. At that time, what will happen? Or let us assume this example itself, that here you are having, let us say, time, item, location, supplier here at this cuboid, where you are having 4 dimensions, and those 4 dimensions are this. So you are going to have a kind of 4D cuboid. Same way, if you are having cuboid, then in that cuboid, you will have the data of 3 dimensions. 2D cuboid, data of 2 dimensions. 1D cuboid, data of 1 dimension. 0D cuboid, that means that all the data are stored at common thing or at a common place. Now, consider this particular example where you are having data with respect to 3 dimensions, and those 3 dimensions are month, product, and region. Right, so this is again 3D cuboid because you are having data of 3 dimensions. Which 3 dimensions? Month, product, region. Now, here these dimensions can be represented in the units also. Right, so for example, month is what? Month is related to time. Right, so here, just a minute. Okay, so here dimensions that we are having like month, product, region. Now we can convert these dimensions into other format also. Fine. So for example, let us say we are having 3 dimensions like product, location, month, or month, product, region. Fine. So what we can do, we can represent the same thing in different format. Right, so we can prepare a kind of hierarchy. So here, the thing that you are seeing here, like here, this hierarchy is for product. Like, let us say products are there. Let us say whenever you are visiting any online shopping website like Amazon, Flipkart, or any other online shopping website, then you are having different products. All products may belong to different category, like electronic products, then home appliances, then clothes, stationery, Fine. So here products are there which can be categorized with respect to different categories, and it may be possible that those categories are also belong to some industry. Fine. So this hierarchy is representing or is for what? Is for this dimension product. Fine. So you can represent this dimension product with respect to these hierarchy. Like let us say, for example, if you want to represent with respect to individual products, that is also fine. If you want to represent this dimension with respect to category, that is also possible. If you want to represent this same dimension with respect to industry, that is also possible. And region. Now, for region, you are having again a kind of hierarchy. You can represent hierarchy or with respect to country, with respect to state, with respect to cities, with respect to office. Now, this hierarchy, this dimension region. And for month, this time. So you can represent the same in other formats also. Which format? Like in years, quarters, months, weeks, and days. Right? So now where these hierarchies are going to be useful. So for example, if I want a data that in the month of, let us say in which month I had sold out the maximum number of electronics items in, let us say, Canada. And so here I am asking for the analysis with respect to country or month wise, or you can say the month wise analysis for different products. And so in short, here you can represent the same dimensions in other formats also. It is up to you that in which format you want. Fine. So in short, you can go upside, downside in this hierarchy based on your requirement for which format or for which dimension you want analysis. Right. So that is about this hierarchies and dimensions, and that is with respect to this sales. You can say that this cube or this 3D cuboid is representing sales volume, which is combination of product, month, and region dimensions. Now this is a kind of example, the same example that we have discussed. For example, here, excuse me, here we are having this kind of 3 dimensions, like again the same that we had discussed earlier, but now we are having with respect to some more data. Fine. So here we are having this date. Here we are having products. We are having country here. Fine. So let us say in products we are having TV, we are having PC, we are having VCR. 3 data is there. Then in date we are representing the time in quarters. Fine. So first quarter, second quarter, third quarter, fourth quarter, and sum. Now what is this sum and all those things that we'll discuss later. Country. This is for USA, this is for Canada, this is for Mexico. Now before that, let me ask one single question, that is I hope that all you are aware of that. Now here date is represented in quarters. So 1 quarter can contain how many months? How many months is equal to 1 quarter? Exactly. Thank you so much for the response, Lutvik. So 3 months equal to 1 quarter. So here we are representing the date or time in quarters. Now, just assume that you are having data warehouse. Fine. And in data warehouse, you are having historical data. That means that data from the beginning. And you are having all the data stored there. Now, just assume that you are not converting that data into this kind of multi-dimensional data, and you analysis, you want some report, what will happen? That you need to have a kind of that kind of tool which can first going to find out all the kind of data, then based on your requirement, based on your query, it is going to generate a kind of analysis and report. So it will take much more time if you are not having this kind of multidimensional data. If you are having this kind of multidimensional data, then you can have faster result, faster analysis, faster report. Why it is so? That you will be able to understand after analyzing this cube, right? So how this to represent or going to provide you analysis, going to provide you some kind of report. So first, for example, let us try to understand this cube or this cuboid, which is having 3 dimensions: product, date, country. Now this particular row, you can say, is representing the data of VCR. This row represents the data of PC, and this is representing data of TV. This row is representing the data of first quarter, this is for second quarter, third quarter, fourth quarter. Now this row is for USA country, this is for Canada, this is for Mexico. Now this is also sum and this is also sum. So you can say that this light orange part, light green part is a sum of individual products and quarters. Fine. So if you want to get the details, like in USA, how many VCRs I have sold in USA, for example. Again, repeating this thing, that I want to know that analysis or that thing, that in USA, how many products I have or how many VCRs I have sold in all the quarters. In all the quarters, then this particular sub portion of this cuboid is going to give the answer. That is why it is sum. Now, what is the representation of this thing? It is representing that in USA, how many PCs I have sold in all the quarters. This represents what? In USA, how many TVs I have sold in all the quarters. And that is the representation of these cubes, these sub cubes, you can say. Now, what is the represent of all these cubes? So this represents what? In first quarter, how many TVs plus PCs plus VCRs I have sold. This, how many TVs plus PCs plus VCRs I have sold in USA, and this is for USA. In USA, in third quarter, how many PCs, TVs, and VCR I have sold. This is representing what? In USA, in fourth quarter, how many TVs plus PCs plus VCRs I have sold. And now what is the representative of this thing? It is representing that in USA, in all the quarters, how many TVs plus PCs plus VCRs I have sold. Right? And now these are for Canada, these are for Mexico. And what is the representative? What is the meaning of this dark blue cuboid? This dark blue is representing that in all the quarters, all the quarters, let us say first quarter plus second plus third plus fourth, in all the quarters, in all the countries, how many items I have sold? All the items I have sold. That is TVs plus PCs plus VCR in all the quarters, in all the countries. Fine. So from this kind of cuboid, you can get this kind of analysis easily, faster, you can say. So for example, if I want that in third quarter, in Canada, how many PCs I had sold. So you will directly get the answer from this cuboid structure. Fine. So again, now this is representing what? This is representing that how many TVs I have sold in USA in all the quarters. Fine. So that is represent, or that is meaning of this kind of data cube. Sample data cube is there. Fine. So in exam, you may ask this kind of question if the exam is theory-based exam, that using some sample data cube, explain different operations that you can perform on data cube. Fine. So this is one sample data. Now what we will see, that which kind of operations you can perform on this kind of data cube. Fine. So now you can perform different operations on this kind of cube, and let us say you are writing a query, or you want some kind of analysis, some kind of report. Then by writing some query, you will be getting some kind of analysis or some kind of results. So on, if you are having the data in this kind of format, like multi-dimensional format or data cube, then which kind of operations you can perform so that you can get the analysis, the report that you want, the results that you want. Fine. So there are several operations that you can perform on this kind of data cube. Go through those operations. Now this is the same thing that we have discussed earlier, but the earlier we had discussed with respect to 4 dimensions. This is with respect to 3-bit dimension, and all these things are represented in this cube. So here you are having 0-dimensional keyboard or apex keyboard where you're going to store all the data. Then out, or you're going to prepare 1D keyboards, then 2D keyboards and 3D keyboards. And here you are having product, date, country, and this is your base keyboard here. Now this is cuboid corresponding to the cube that we have seen here. Here we are having product, date, country, product, date, country. You can first have all the data stored at particular thing, then you're going to separate it with respect to 1D individual dimensions, then combination of 2 you're going to prepare, then you're going to combine, you're going to prepare 3D cuboid or base cuboid. Right, so this is going to be prepared with respect to, or based on this cuboids. So this kind of question can be also asked, that prepared, let us say, different cuboids or cuboid hierarchy for the data where you are having all the data of, let us say, product, date, country, and represent with respect to data cube by assuming some items, or by assuming some kind of format and all, assuming some countries and all. Now these are the operations that you can perform on data cube. Right, so first is roll up, then drill down, slice and dice, and pivot. Now let me give a brief about all the operations. So 4 main operations are there in short. Right, so roll up, also known as drill up, drill down, also known as roll down, slice and dice, and pivot. These are the major operations, or main 4 operations that you can perform on data cube. And these operations are also known as OLAP operations, because in OLAP systems you are going to prepare data cubes and going to perform operations on data cubes, and you're going to have your results or analysis or reports. So in which operation what? Right, so in roll up, what we are doing in roll up, we are climbing up the hierarchy. Now what is hierarchy? The same thing that we had seen earlier. Right, so these are the hierarchies. Like this is the hierarchy for, let us say, product, this is hierarchy for location, this is hierarchy for time. Fine. So in roll up we are climbing up the hierarchy. In down we are going downwards in the hierarchy. Right, so roll up we are climbing up. In drill down we are climbing down the hierarchy. In slice and dice what we are doing for slice that we all know. Let us say you are having a cube and you are just cutting a slice from it. Fine. So what is slice? Dicing. In dicing, you are preparing dice from cube, and in pivot, you are rotating the dimension. Fine. So all these operations we are going to discuss in detail now. And other operations are also there, like drill across and drill through. So those are other operations. Now, this image is representing all those 4 basic operations or main operations, like let us say drill down, roll up, slice and dice, and pivot. Right, so let us understand each operation in detail. So again, repeating this part, that drill down, we are climbing down. Right, so first of all, let us understand the roll up operation. Before that, first of all, this cube. What is this cube? In this cube, you are having 3 dimensions: time, which is in quarters; item, which is with respect to different types of items like home entertainment, computer, phone, security; and other dimension, location, that is with respect to different cities. Now, counts are also there, like 605, 825, 14, 400. That is representing what? That, let us say 605. What is 605? 605 is representing that in first quarter, in this Vancouver city, total 605 items I have sold in total 605 home entertainment items I have sold in first quarter in Vancouver city. Like now, next 825. 825 is representing that in Vancouver city, in first quarter, I had sold total 825 computer items. Now, what is this 440? 440 is representing that in Chicago, in first quarter, total 440 home entertainment items I have sold. And that is the representation of this cube. Now, let us discuss the first operation, that is roll up. Now we are going to climb up in the roll up operation, and here, as you can see here, that roll up on location. Here we are performing the roll up operation on location dimension. Now what will happen if you are going to climb up? Fine. So for that, let us see that hierarchy. As you can see here, that location is there. You are having different cities, you are having countries and regions. Right? So you are having, or you are climbing up in the hierarchy. Right? So we are having different cities. We can shift up to state or country. Right? So if you are not going to consider state, then you can also climb up to country. So here I have considered countries in the upper hierarchy. What they have done, are rolling up, they are performing roll up operation on location dimension, where we are having different cities like Vancouver, Toronto, New York and Chicago. And here they have considered the countries. So what they have done here, they have also mentioned in the curly braces, or sorry, round braces, that from cities to countries. Up on location, into bracket, from cities to countries. So they are climbing up in the hierarchy from cities to countries. So as you can see here, that other dimensions are as it is, like time is in quarters, item types also same, but they have converted, or they have considered, combined all the data from different cities which are belonging to the same country. For example, Chicago, New York, that is Toronto, Vancouver, that is in Canada. So here, Chicago, previously, Chicago and New York were having different counts like 440, 1560. Now they have considered the countries. So USA is having count 2000 now. Now, excuse me. Now, Canada, Vancouver, Toronto is in, let us say, Canada, and they have merged it. They have considered countries instead of cities. So they have this data of Vancouver, Toronto, 605 plus 395,000. Right. So now you are having in terms of countries, not cities. Fine. So for example, when it is useful, when I'm saying, or when I want the analysis country wise, let us say so many companies are there which are doing business country wise in multiple countries. Let us say Range Rover is there, which is selling the cars in multiple countries. Now they can have the analysis in terms of cities, they can have the analysis in terms of countries also. So whenever they want the analysis country wise, then they're going to perform this kind of roll up operation if they are having cube in cities. If they are having the cubes in country wise and they want the analysis city wise, then they're going to perform drill down operation. Fine. So we are performing roll up operation because our main cubes are having cities. If you are having the cubes in countries and you want city-wise analysis, then you are going to perform drill down operation. Right, so let us see the drill down operation now. Okay, so for example here, this let us consider that this cube, again same cube. Now drill down on time. So we are going to perform drill down operation on time, where we are going from quarters to months. Right, so we are going to separate out each quarters in month. So for example, quarter 1 will be having January, February, March, quarter 2, April, May, June, then July, August, September, October, November, December in quarter 4. Right, so rest of the dimension will remain same. This is time. Now it is in months. Previously we were having in quarters, and again this location dimension is hierarchy, that is city. Now here with respect to Vancouver city, item, Vancouver city security item in first quarter. So total we have sold 400 items. So same things are divided now. Previously it was combined, now it is divided. Like for example, security items in first quarter. First quarter is containing January, February, March. Vancouver city. So it is divided now with month wise. It is divided month wise, like in 150, February 100, March 150. If you combine it, you will get again the same count, 400. Fine. So we have shifted downwards in the hierarchy here. That is from quarters to months. If again you are going to perform drill down operation, you will be considering weeks. Fine. So drill down on time from months to weeks. Again, if you're going to perform the drill down operation, then you can say that drill down from weeks to days. That was a drill down operation. Now let us consider slice and dice. In slicing, what we are doing, in slicing, let us, you are having this cube now. You are going to consider a slice from this cube. Fine. So for that, what you are going to do, you are going to consider one dimension as constant, and you're going to consider that slice. So simple, for example, if you're going to perform slicing on this cube for time equal to q1, time dimension by considering let us say q1 as constant. Right, so what I will get all the data of first quarter. If you want to perform slicing on the same cube with respect to q2, then you will get all the data for with respect to second quarter. So slice for time equal to q1, that means that you are going to perform slicing on this cube by considering first quarter. Right, so as you can see, you are going to have this slice from this cube. Fine, so you are having home entertainment, computer, phone, security, Vancouver, Toronto, New York, Chicago, and with respect to first quarter Q1, so we'll get the data 605, 825, 14, 400. Fine, you are here. You can have, let us say, 395, 1560, 440. Fine, so this slice you are having with respect to first quarter only. So in short, you can say that you will get all the data of first quarter from this keyword. All the data from first quarter for all the cities, all types of items. You can also perform slicing with respect to cities, like slice for city equal to Vancouver. You will get all the data of Vancouver city with respect to all quarters and all types of items. So for any dimension, for any particular value, you can perform this slicing operation and you will get all the data with respect to that particular dimension. Now pivot operation. Slice and dice, the names are in the same line, but slicing and pivot both are relevant, or both are dependent to each other. So for example, after performing this slicing operation, let us say on y-axis I want item to me that in which format I want the analysis, or graphs or charts. So I want to have locations on x-axis and items on y-axis. So what I can do, I can perform pivot operation. Simple. Pivot is nothing but pivot is rotate operation. So I'm going to rotate this dimension, or this you can say that dimension. I'm going to exchange the dimensions, you can see. So for example, previously on y-axis I was having location, x-axis I was having items. Now it is exchanged. On y I am having items, and on x I am having location. And that is pivot operation or rotate operation, both are same. Now dice operation, that is dicing. Dice operation is nothing but you are going to consider sub portion or dice from this cube. Fine, so please, okay, here you are having pivot operation. You are not going to mention any kind of values here. While performing dice operation, you are going to write a kind of query, or how that which dice you want. So for that, just focus on this query, you can say. So dice for what? Dice for location equal to Toronto or Vancouver. You are going to consider these two cities, Toronto, Vancouver, and time is equal to Q1, Q2, equal to Q1, Q2, and item equal to home entertainment or computer. Fine, so you will get this dice from this cube, which is having the data of Toronto, Vancouver cities, quarter 1, quarter 2 quarters, and home entertainment and computer items. So this dice you are going to consider from this cube. And so two values from each dimension. you're going to consider, and you are going to have this kind of dice from right. So where you are having home entertainment computer and time Q1 or Q2 and location equal to Toronto or Vancouver. Fine. So that is all this operation. This is we are rolling up. We are performing drilling down operation, slicing and pivot, and dicing. Right, so these are the major operations or OLAP operations that you can perform on data cube. Okay, so anybody, any kind of doubt, any kind of queries in any of these operations? Anyone, any kind of query, any kind of doubt? Thank you so much for the response, Rutvik. Great. Anyone, any kind of doubt, any kind of queries? Anybody else? Okay, fine. So I hope that there is no queries. Fine. So in the next lecture, we will see the data warehouse architecture. Fine. So this is data warehouse architecture, and these are the different parts of it. And we'll also see the rollup, mollup, and all those things. We'll also see the data mart and all. Right, so that we'll discuss in the next lecture. And I hope that there is no queries now. If anyone is having any kind of queries, write in the comment box, or you can unmute yourself and ask the query. Thank you so much for the response, Shubh. Anybody else, any kind of queries, any kind of doubts? Great. Fine. So that's it for today's session. I have one more session today, so that we'll discuss in the next lecture. The data warehouse architecture and all those things that we'll discuss in the next lecture today itself. Fine. So for attendance, please write down your full enrollment number in the comment box.